So hey guys, welcome back to my channel. Hope you are doing extremely well. This is your very own master this side, and today we will be solving another problem of the day. So you can see the question is check if all leaves are at same level. So let us see what does the problem say. The problem says that you have been given a binary tree, right? And you have to return true if all of the leaves of this tree are at same level. And if they are not at same level, then return false. Alright. So I have taken two examples of binary trees. Let us first figure out what are the leaf nodes. Leaf nodes are the nodes whose left as well as right child are null, right? That you cannot traverse further from leaf nodes. So in this example, the leaf nodes is 4, 5, correct? And in this example, the leaf nodes are 4, 5, and 3, right? Because 3 is also right, left is null and right is null, correct? I hope we are on the same page up till now. So now let us see if this tree will return true or false, right? So you can see this is my level 1, this is my level 2, this is my level 3, and my leaf nodes are occurring at level 3 only, so it will return true. But for this tree, this is my level 1, this is my level 2, and this is my level 3. So if I mention the levels of the leaf nodes, it will be 2, 3, and 3, right? So you can see it contains undistinct numbers. That is, if it is a set, then it will contain at least two elements, right? In that case, it will return false. So I hope you are clear with the input and output scheme of the today's problem. All right. Now we have to understand the implementation. Implementation. The implementation says, as we know, we will discuss the brute force approach first. The brute force approach. What is the brute force approach to solve the question? I will say calculate the levels of all leaf nodes and store them in a set. Store them in a set. At last, if set's size is greater than equals to 2, return false, else return true, right? This is my scheme, right? If I have like here only I computed all the levels of leaf nodes 2, 3, and 3. So set will be 2, 3, and set size is greater than equals to 2, so it is returning false. For this, set will be 3, 3, which will shorten down to 3. Set size is 1, it is returning true, right? This is my approach. All right, but it will take a lot of time because calculating the leaves levels of all the nodes will take an let's say O of n square time. Why? Because I will traverse the tree. Whenever I will encounter a leaf node, I will calculate its depth by calling O of n time, right? So it will be O of n square. Pretty inefficient. Let us try down to efficient approach. Let us drive down to efficient approach, the optimized approach. The optimized approach is, see, the level of the question is given to be easy, right? So I will not make it too hard for you. It is very easy if you know about level order traversal. What is level order traversal? Suppose you have the tree 1 connected with 2, connected with 3, 2 connected with 4, connected with 5, connected with 6, right? This is your level, this is your tree. So the level order traversal for this tree is first this level, that is 1. Then left to right this level, second level, that is 2, then 3, then 4, 5, 6, 4, 5, 6. This is your level order traversal. All right. I hope all of you know about level order traversal, how we perform the level order traversal. If you don't know, don't worry, we will cover that also in the video only. Plus, please stay connected. Okay. So a level order traversal will work like we will implement a queue, right, of type node star. Name it as queue only. Now q dot push root. Root is 1 here. This is 1, right? So this is a queue route now. It has 1 in it, right? As usual, I will run while queue is not empty, right? This is the main basic step of every algorithm up till now. So 1. Now you can see level 1 contains only one node. Level 1 contains only one node, and my queue also contains only one node. So what I will do is my int n will become equals to queue dot size, right? So n will contain 1 right now. Now what I will do is for I equals to 0 to n minus 1, that is it will run n times. I will store my node star cur equals to q dot pop, right? The first node. So q becomes empty and cur contains this node. This is my cur right now, right? I'm telling you level order traversal now. After level order traversal, I will just take two steps and I will find you the answer of today's problem. So my cur is right here. After that, if my curse left is present, that it is not null, then q dot push cur else, oh, else sorry, if my right is present, then q dot push, it will be curse left and it will be curse right. So what are we doing is we take out one. I see that 2 is also present, 3 is also present, so put 2 in it, put 3 in it. Also, when I take the pop, if I want the level, then I will make a vector of level here, vector int a dot push back curse data, and after this suppose I have an answer here which is a type of vector int answer dot push back a, right? And this loop will end and I will return my answer for the level orders. So my answer would look like, firstly I pushed a, so a becomes 1. I pushed that into the answer, so my answer becomes something like this right now, right? Now my queue contains 2 and 3. I will repeat the same steps for 2 and 3. My size is actually 2 now, so n will become 2. I will have to pop the items 2 times. First my cur is 2, so I will pop that out, push it into this a vector, and I see 4 is also present, 5 is also present. So 4, 5, q is popped out. Same for 3. Push 3 in it, and 3, 6 is present, so push 6 only in it and pop it out. So this is my vector 2 coming to vector 3. Now n becomes 3, 4, 5, 6 is present. So first 4. So when you pop out 4, you see neither left nor right. For 5 also, for 6 also. So last vector becomes 4, 5, 6. And as you can see, our vector was 1, 2, 3. That is 1, 2, 3, 4, 5, 6. 4, 5, 6. Correct? This is my level order traversal. Okay. Now I said that take two steps to make you reach the final answer. What I will do is, I'm saying, suppose it was something like 7 here, then it will return false, right? Because the leaf level here is 3 and here is 4, right? So what I will do is, after implementing a queue here, I will take my leaf level as -1, right? After popping it out, I will check here that if my curse left is equals to null and my curse right is equals to null. If this is true, that means that my cur is a leaf node, right now. Now three conditions can arise. If my level, I will also implement a level here. Firstly, for root my level is 1, so level is equals to 0 right now, and here level plus plus, so that I am getting the level plus plus, right? So I'm on the same level. If my level equals to leaf, continue, no problem. If it is not so, then else if my leaf is equals to -1, that is I have not encountered leaf, this is my first leaf, so assign level to leaf equals to level. Else if level is not equals to leaf and leaf is not equals to -1, that is I have encountered a leaf before which is not at this level which is before, so in that case return false, right? And here if return false has not executed for the whole traversal, then return true. These are the only steps, right? So what I'm doing is, when I come to this When I come to the fourth node, I assign 3 to my leaf, and when I come to the seventh node, I see that 4 is not actually equal to 3, so return false. So let us implement it real fast. And in the meantime, please subscribe to my channel. And if you're new here, please subscribe. And if you're liking the video, please do hit the like button. It gives me a lot of motivation. Also, I'm thinking of bringing a placement course right from the scratch. So if you want it, please engage with me in the comment section and give a +1 for placement course. I will bring it to you. Now coming to the code area of it. So bool check node star root. Okay. First of all, if my root is equals to null, in that case return true, because if I'm standing at null, then I have to return true. I don't think this needs an explanation. A second step was to make a queue of type node star, mention it as queue dot push root. My level will now be 0. Now while my queue is not empty, what I have to do, let me zoom it down a little bit and make some space. Yeah, so while my queue is not empty, I will take out the node which is at top, queue dot front, queue dot pop, right? Now, sorry, this will be intent queue dot size, right? And my level will be incremented. Now for int I going from 0 up till n I plus plus, my node star current node will be q dot front q dot pop to eliminate that node from the current tree. Now the condition can be if my current's left is null and my current's right is null. That is, I have encountered a leaf node, right? In that case, what I will do is, if my leaf equals to -1, then leaf becomes level. Else if my leaf equals to level, leaf, I'm skipping this, I'm just saying if leaf is not equals to level, then return false, correct? And after that, if my curse left is not null, then q dot push curse left. If my curse right is not null, then q dot push curse right. Right, this was my whole algorithm. I just have to mention with level a leaf here which is equals to -1 right now. So I hope the code will work. Just mentioning, if I've not encountered a true here or a false here, then return true at last. Let's try to combine on it. Please subscribe to my channel. Please subscribe to my channel and do comment if you want a full placement course. It will take time, but yes, I will be consistent. I will drop the full course. And as you can see, we have completed our today's POTD and our current streak is 55 days. Thank you for watching. Have a nice day. Until then, keep coding.
जो जानते नहीं उनको भी लगूं फेमिलियर बना मैं शख्स नहीं बेशक करूंगा